Well, I hope you enjoyed both of those demonstrations with sodium and water. So let's discover the chemical equation that occurred in both of those demonstrations. All right, so for example, sodium. We figured out sodium is a solid. It is a silvery metal. It is actually very soft. Now I use a razor blade to cut it. However, you could use a butter knife with a little bit of pressure and it would cut. Sodium is stored in water. And the reason for that is that sodium reacts with water, and there's water vapor in our atmosphere. You will not find any elemental sodium in nature. There's sodium ion, most certainly, but not sodium metal. Now, what did the sodium react with in this example? Well, the sodium reacted with water, and we typically write water as H2O, but in this particular case, we're going to write water as HOH. Its cation and its anion components respectively. Okay? And the sodium is going to displace one of these. And sodium is a metal, it forms cation, so it's either going to displace a metal or it's going to displace the cation. And the cation that it will displace, of course, that is a non-metal, is the hydrogen. And this is characteristic of a single displacement reaction where you have an element and a cation-anion combination. So the sodium is going to displace the hydrogen. Now on the product side, those are the two reactants, by the way. The sodium metal and the water are the two reactants. On the product side, you will have an element and a compound. That compound will be composed of a cation and anion. The first is the element. The element is the hydrogen. And how do you write hydrogen? Well, I always tell my students, take your right hand and put an L on it, and then flip that down, and you get the number what? 7. And that is, there are 7 diatomics. And you should see that those 7 diatomics correspond to what's on the periodic table. It just happens to be that hydrogen is one of those. So therefore, that should remind you that the formula for hydrogen is H2 because it's a diatomic. And hydrogen, of course, is a gas. Okay, and that is what you observed, is that the sodium displaced the hydrogen in the water and it produced hydrogen gas. Now you know that hydrogen gas is flammable, and therefore you should have seen a little bit of a flame on the surface of that water, because this reaction is so exothermic that some of that heat ignites the hydrogen, and that hydrogen gas burns, and it burns a little bit of that sodium on the surface of the water. That's why you saw that fire on the surface, those sparks that you saw, and that pop at the end. Okay? The other product is sodium hydroxide, and this is in solution. That's why the AQ here. So that's a sodium ion and a hydroxide ion. Now, in the second demonstration, there was something added to the water, and I didn't denote that initially, but the thing that I added to the water was a chemical compound called phenolphthalein. And phenolphthalein is an acid-base indicator. Okay? It is colorless in an acid solution, and it is a pinkish color in a basic solution. That sodium hydroxide produces hydroxide ions, which is, of course, a base. That's why in the graduated cylinder, it became pink in the water portion of it. Okay, let's get a balanced equation for this too. Okay, so you're going to put a 1/2 in front of that hydrogen gas and then multiply the whole entire equation by 2, and then you get this right here. Now, I've indicated the phenolphthalein right here because the phenolphthalein turns pink in a basic solution, and that's why it is pink in the water layer in the graduated cylinder. The upper layer was mineral oil. And of course, that's why the sodium just kind of floated in the mineral oil a little bit and then fell through the mineral oil because the sodium was more dense than the mineral oil, and water is more dense than the mineral oil. So the sodium reacted. Once it hit the water, then it reacted with the water, produced bubbles. Those bubbles that was hydrogen gas, and you could actually observe those bubbles in the graduated cylinder that were rising up in the oil layer. Okay, I'm hoping that you're going to see more demonstrations. I am the Crazy Hat Chemist, and of course, you can't end except with a crazy hat. So give me a thumbs up if you enjoyed that video, and please subscribe to my YouTube channel. Look for more Crazy Hat Chemistry demonstrations on my YouTube channel. See you next time. Bye for now.